Hello, everyone. Thank you for joining us, and welcome to Bas Dijkstra's talk, Who Will Guard the Guard Themselves? Hey, Bas, how are you?
Classic mistake. Yes, I'm doing great. How are you?
Great, great. Thank you for joining us. So I'll quickly introduce your talk. So in your talk, Who Will Guard the Guard Themselves, you'll see a number of ways in which test automation can mislead you. Bas will also share some strategies, tactics, and tools that can help you regain trust in your automation and build automated tests that you can rely on. So as always, feel free to ask questions during the talk on the right side panel. And then at the end, we'll have 10 minutes where Bas will answer the questions. And are you ready, Bas? Shall we get started?
I am. Let me quickly, because this is all live and there we go. If all goes well, you can see my screen now. Ines, can you confirm that, please?
Yes, we can see it.
Excellent.
Right. Take it away.
Okay. So thank you for that introduction, Ines, and thank you for having me. And thank you to all the attendees who for carving some time out of your day to join me in this talk. My name is Bas Dijkstra. As Ines already said, I'm a test automation consultant and trainer from the Netherlands. I've been in test automation for some 15 years now, mostly as a consultant, but as I said, last couple of years, also as a trainer. I blog a little, I write something, I do some public speaking, stuff like pretty much, yeah, a lot of different stuff, really. The topic that I want to talk to you today about is, as you can see from the title slide, who will guard the guards themselves? Or, as Ian has already introduced the talk, I want to talk about some ways in which your automation can deceive you. And some of those ways might be obvious, might be really visible, but some of them might not be. And that's what I wanted to talk to you about today. So first of all, this is not a surprise for those of you who are listening. Testing is everywhere. Testing starts during development, maybe even before development. Testing is a continuous activity. It's not something that's tacked on at the end of the development process anymore. It's something that happens continuously by your developers, by your testers, by your end users, by product owners, by analysts, by everybody, really, hopefully, these days. And there's because we want to keep up with these ever increasing demands of wanting to reliably deliver reliable, high quality software at a predictable pace. So we need to test all the time, and we need to test early, we need to test often, we need to test continuously. And then the big buzzword, the magic solution, if you still believe some people and some of the marketing schemes out there, the be all end all solution to this is test automation. If you write enough automation and if you do it well, you should be able to deliver high quality software reliably at a sustainable, at a predictable pace, or at least that's what the marketing copy tells you. That if you buy our tool, if you use my open source library, if you just use our automation solutions, then everything will be rainbows and unicorns. But is that really true? It can be, or at least I've been in test automation for 15 years now, and I've done a lot of horrible test automation. So I know enough about ways in which test automation might not work. I've spent too much time and effort writing automation in the past that was just plain worthless. But if you do it well, test automation can definitely be an enabler of releasing high quality software reliably in a predictable at a predictable pace, at a predictable velocity. The problem is, to me, one of the things that so we spend a lot of time working on automation. We spend a lot of time coming up with ideas for automated tests. We spend a lot of time writing our automated tests. We spend a lot of time running and maintaining our automated tests, and that's great. That's great. That's also how I make a living these days. Most working with teams and organizations, helping them improve their test automation efforts to better and more efficiently support their testing. One thing I don't think enough people spend enough time and effort on, with all this time and effort spent on writing and running automated tests, what I don't think is spent enough time and effort on is the quality of those automated tests themselves. So, and that's where the title of this talk came from: who will guard the guards themselves? Or, well, in Latin, it sounds even more impressive. This is pretty much all the Latin I know, so don't be fooled by that. It's so yeah, who is because your automated tests are your guards, and the higher the level of automation is in your software development and delivery process, the more likely it is that your automated tests are pretty much the only guards, the only safekeepers that keeps code from written on a developer's machine from entering your production environment. And so we spend a lot of time writing these guards and writing this automation, and spending a lot of time increasing our automation coverage on all these different levels that Johanna in the previous talk also had, but she talked about the pyramid, and we do write a lot of automation on all these different levels: unit tests, integration tests, end-to-end tests, performance tests, security tests, all different kinds of tests. But what's the quality of those tests? And is that important? Is the quality of these tests important? I think it is, and you probably also say, well, yes, the quality of our tests is important, but do we spend enough time actually diving deeper into and getting a good feel for what actually is the quality of our automated tests? And I believe there's some room for improvement there. Because generally, what testing is all about, and test automation as a means of supporting testing is confidence. I want to be confident about the ability of my product to perform a specific function or process X. I want it to do something. And when I use automated tests to build that trust, to get the information about the quality of around that specific function, and to get some insights into, is this performing as expected? Is this functioning as expected? If you use test automation for that, that also means you need to be able to trust your automated tests around that function X. And again, we spend a lot of time building fantastic products. We spend a lot of time writing automated tests. So the first two parts of this equation, I think that's where we spend enough time on developing features that our customers actually want, and on writing automated tests that we use to gather information about the quality of those features. But what I don't think we spend enough time on is the right-hand side, or the bottom part of this equation is, and how far do we trust our automated tests? What's the quality of our automated tests? Because these automated tests, they can be they can deceive you in a couple of ways. And that's what I wanted to talk to you about today, and give you some examples around how your automated tests can deceive you, how your automated tests can misinform you. And I'd also add, I don't just want to be the bringer of all the doom and gloom. I also would like to give you some practical tips and tricks and even some tools that can help you get a better insight into the quality of your automated tests. Because again, if you want to build confidence in the quality of your product, you need confidence in the quality of your automated tests as well. There are a couple of ways in which your automated tests can deceive you. And the first one, and that's the one you've probably seen them a lot, the false positives. What are false positives? False positives are tests that fail. But there's nothing really wrong with your application. So tests, it can be any type of test. It can be unit test, integration test, end-to-end test, any kind of test that fails or that gives you some information that something is wrong with your application under test. But there's nothing actually wrong with your application under test. It's the test itself that's the problem. That's what I talk about when I talk about a false positive. And the problem is these tests are annoying. They generate a lot of noise, a lot of misinformation, because you get the idea everything is going wrong with your application on the test. Well, upon further inspection, it's actually the test that is the problem. Some of these false positives are continuous, so tests that are continuously failing. And whenever I see, as a consultant, as an external consultant, I tend to work with a variety of teams and organizations. My first question always is, why didn't you fix that? And by fix that, I mean either fix the test or throw the test away, because a test that's continuously failing is worthless, because it doesn't give you any. The only reliable information that it gives is that your test still fails, that your test is still faulty. It doesn't give you any valuable information about your actual application on the test. So, and my first question is, why didn't you fix that? Or by fix, I might mean throw that away, because again, it's not a valuable test. The slightly more annoying ones are the tests that sometimes fail and sometimes pass. Some people might call them flaky tests. That's terminology that I hear a lot in relationship to these type of failures. I don't think it's a flaky test. It's a flaky approach, or it's flaky test code. It's not the actual test that's flaky. It's just probably that the test isn't reliable or stable enough, or maybe it's something with your test data, with your test environment. We'll look into that in the next slide. But these are the tests that, well, let's just try and rerun them, and maybe if all goes well, we see a green check mark the second or the third or the fourth time we run it, and then we say, oh, test passed, everything is okay. Which isn't the case, because, well, still your test failed 3 out of 4 times. And that's your test trying to tell you something. What I tend to say sometimes is don't sweep that information under the rug. And with rug, I mean retry until green. Please don't do that. If you see these tests, please don't just retry your tests just for the sake to getting it to green once. Please try and analyze and fix the root problem of that. Why did the test fail in the first place? Because that's information too. It's information about your test is not reliable enough to pass the first time. So a lot of times at these false positives, and especially the the intermittent ones, the ones that fail every now and then. That's because of problems with test data. A specific user might be accidentally inactive, or a specific data entity that your test relies on might not be in the database at a specific moment in time because you forgot to create it before you ran the actual test, for example. Things like problems with test environments, dependencies, downstream dependencies that your application needs to process some data might be down or slow or responding in any other type of unexpected way. And these are also often sources for false positives. Backend components that respond very slow, which means that your website takes a lot of time to load and render, which in turn makes your user interface driven Selenium test fail because, well, you're only waiting a couple of seconds before that button becomes enabled, and it takes just a couple of milliseconds more than that. So that's often a problem with, again, a timing or synchronization. Your waiting strategy just isn't up to par. So that's the third cause of that. Well, the third cause of these false positives, of these tests that fail, where there isn't really anything wrong with your application or the test, is just something in your test environment or with your test data or with the way you synchronize your test code with your application that is that might need some improvement there. So I've written a lot of these false positives in the past, and just I want to illustrate one way of dealing with this. I want to tell you a little story about a project I worked on, kind of recently. There was a project where we had a suite of automated tests that I was maintaining and running. I wasn't the person, to be fair, that initially created that automation setup, but it was my responsibility. So and I take full responsibility for that. And we had this big TV screen in our team room, and every morning we walked in, we looked at that TV screen that showed us the result of a number of Jenkins builds that ran overnight. And typically it looked something like this. So some tests passed, a lot of them failed. So we ran our tests again, or maybe we just, I don't have time today. Let's wait what it looks like tomorrow. And maybe the next day or the next test run, it would look something like this. And on a good day, it might look similar to something like this. If you had a good day and a lot of tests passed, but still not all of them. It never, however, looked like this. So that's again, I've been working in test automation for some 15 years now with a lot of different, and this is eerily common still with a lot of teams, that they have a lot of tests and a lot of them are failing. They're either sometimes failing or always failing, and basically their test results or their test report or their build monitor always looks something like this or this or this. Sometimes also like this, but that's not what our monitor looked like and what our test reporting engine looked like. The problem is, once that happens enough, once those tests keep failing often enough, people are going to start to walk away. They start to not trust and not believe in and not believing in what they're seeing or what they're reading, because they know, those automated tests, well, we don't really care about those anymore. They keep failing over and over again, and we'll just test it ourselves again, because those automated tests, they can't be trusted. And this is pretty much the beginning of the end of your automation journey. If you spend so much time and effort creating your initial test automation setup and maintaining it for months or maybe years, but it's still, people have no trust in the results. They don't use the information. They don't base their next actions on the results of those automated tests. And you could just as well not have any automated tests at all, because it doesn't deliver any value. It doesn't contribute to shortening the feedback loop, speeding up the process of gathering information, because the only information that your tests communicate is, I'm unreliable, and that's it. So the way we dealt with this is by doing this, and just turning off all of the tests, turning off at least the notification of the results of all of those tests. And then we went to work, and we dug really deeply into what was the cause of the why are those tests so unreliable? What was the problem here? In this case, it was synchronization a lot of times. So we tested a sort of message bus kind of system. So a system that routed messages from one system to the next. And it just so happened to be that that often took a little longer than the test really expected. And so it took us a while to find out what the root cause was and how we could deal with that in our tests. But finally, we had a solution to that, and that was the start of. And then we slowly had to. What we didn't do is just enable all of the tests again, because there was still a lot of risk that we would end up with a build monitor that looked like this or this or this. What we did instead was find one test and that we knew we could rely on, and just report on that every single time, because it kept on passing over and over and over again, for the right reasons, obviously. And only when we saw that it kept on telling us everything's okay, we added another one, and then another one, and then some more, until in the end we ended up with the same test coverage that we initially had, but now with tests that we knew did not fail when they weren't supposed to fail, because we took our time finding out what's the root cause and finding out what's the root cause of our failing tests, and really diving deep into it. Is it our test data? Is it our test environment? Is it timing and synchronization? In the end, for this case, it turned out to be a mix of our test environment and our synchronization strategies in our automated tests. So slowly, but that took us a couple of months, I think, even, to regain that trust in the results of our automated. Before we knew, and before we got signals that people were really acting based on the results of our automated tests again. So that took us a long time. So please, I will let my lesson be here that don't let it get so far for people to walk away on the results of your automated tests, really. So that's the false positives. The tests that say, I'm unreliable, I fail a lot, and when there's nothing really wrong with your application under test. There's also what I call the silent killer, of test automation, and that's the false negatives. Those are the tests that keep on passing, even if there is something wrong with your application. So you write tests to get information about is this specific feature or function or method or whatever class working correctly, and they keep on saying, well, yes it is, but they don't pick up any bugs in your code. And again, while false positives are annoying, false negatives are the real silent killers. But because what happens is that they say, well, everything is fine until your software hits production, and then your end user say, well, no, this is a bug. I didn't expect it to do this. And you keep, but didn't we write any tests for that? Yes, we did. We wrote all kinds of automated tests that gave us the information that everything was working correctly. And then again, then your users start working with your application and say, well, there's all kinds of bugs in there. And that's because of these false negatives, these tests that give you a false sense of security, really. Let me give you an example, a very basic example. I have a car class here with a single property horsepower, so the number of brake horsepower for this car. And I have a method that determines whether or not this is a powerful car, and totally arbitrarily I say, well, if the amount of brake horsepower is upwards of 400, it's a powerful car. That's it. And I have a test. I have a test that tests, well, that a car with 200 brake horsepower is not a powerful car. Yay! 100% code coverage. With 100% code coverage, I mean by running this test, I exercise 100% of the lines in my application code. And that's what it's metrics like these that a lot of people and teams look at when they tell you anything about the quality of their automated tests. So I've worked in teams that boasted themselves on, we have 100% test coverage or 100% code coverage on all of our tests in every area of our application. Yay, that's nice. So yeah, you've wrote enough tests to exercise every single line of code in your application. The problem is just relying on code coverage isn't really a very good estimate. It doesn't really give you any information about the quality of those automated tests. So, for example, after a long, hard weekend, your senior developer comes in on a Monday morning and they decide to start working on a new feature or refactoring some code. And at some point, they make a mistake. Sorry to burst your bubbles, developers do sometimes make mistakes. And they rewrite this incredibly complex routine so that it accidentally always returns false. And then they run their tests, in this case, and their extensive 100% code coverage set of unit tests. All the tests pass, still 100% code coverage. So the code is being checked in, goes into production, and everything breaks down. Obviously, the real world is a little less simple and straightforward than this specific example, but you get my point, hopefully. Developers make mistakes, and just relying on code coverage and the result of your test, it's not always enough to warrant a solid sense of security, a solid sense of confidence in the quality of our application, because we have passing tests here, we have 100% code coverage here, but still there's a problem. It's just that our test didn't detect it. So the lesson I want to share here is a lesson that I learned from reading a lot of articles from Martin Fowler, and one of the aside from all of the text things that he wrote. I love this little graphical, this little image that he shared. Test coverage is a great way of pointing at code that's not yet been tested. And that goes, and he was talking about unit test coverage, but this applies to every kind of test, really. So it's a great way to point at to find code that's not yet been tested. As a quality target in and of itself, it's worthless. And I hope that this admittedly very simple example showed you that just relying on code coverage, I'm sorry, but that doesn't really tell you anything about the quality of your application, and B, the quality of your tests. So how to trust your tests again, as how to make sure that you don't accidentally introduce a lot of false negatives, either initially when you're writing your tests or over time as your application evolves, because in both situations, false negatives might suddenly pop up. Maybe you write a test that accidentally always passes, or as a developer changes something in your application that immediately turns your test into a false negative. What I also is test your tests, really, as a tactic to deal with this. And one of the most efficient ways to do this is code reviews for your test code. Is have someone else look at what your test is actually doing. That might be a developer, a fellow tester. I don't really care. I don't care if it's the janitor but well, maybe not the best example, but have someone else review your test code, because what may be very difficult to spot for you is maybe incredibly obvious to them. Oh, you missed a case here. Oh, are you really sure that your test can fail if you write it this way? So that helps filter out a lot of these untrustworthy tests. Periodically, go through your test suite and see if they can fail. The best way to do that is by changing your application slightly, so and run your existing suite of tests to see if they fail, if they pick up on the change that you made on purpose. If that doesn't work, if that's inefficient, and often unfortunately it is, at least try and change the expected outcome of your test and see if it fails that, just to make sure that it actually can fail, that it actually can produce a failure in your test report. And so this is something that I always tell in workshops and training courses as well. If people have written their first test and they're really proud of it, and that's totally fine, totally cool, but are you sure you're actually testing what you think you're testing, and are you sure that your test can fail? And so those are questions that I ask myself a lot when I'm writing tests myself, and I ask that question to others that I work with a lot as well, to see, hey, are you sure that your test is actually doing what you think it is doing? And how do you know? And one way is to review your test suite often. Go through your set of tests at certain points in time, just to say, well, are all of those tests still producing reliable information for us? That's because that's super important, and things change over time, and those changes they present themselves because your tests suddenly start failing, but sometimes they don't, and because the tests keep on passing, they don't pick up any bugs in your application anymore. And finally, don't be afraid to throw tests out. It's yes, you've spent a lot of time creating those tests and maintaining them, and they've become like a child to you. I know. But at some point in time, when you just feel, well, they're not just that valuable anymore, don't be afraid. Don't be afraid to throw them out, because a test is only as valuable as the information that it produces. But what I keep on saying, and this is something that it's easily tweetable and stuff like this. Never trust a test you haven't seen fail. Really, please don't. If I see tests, people that, well, I've run this test 500 times and it passed 500 times with flying colors. Are you sure it can fail? That's something that I feel people should ask themselves and others more often. Are you sure that this test can actually fail? If it can't, if it doesn't fail when it should, you have a false negative on your hands, and that means automatically it's a test that cannot be trusted. Do you have to do all of this by hand? No. There are some tools, as a specific type of tool that can help you test your tests. And those are mutation testing tools. For those of you unfamiliar with mutation testing tools are tools that automatically generate small changes in your application code of in your or maybe in your application bytecode or your binaries even. Then they run the tests, and typically that's unit tests, but sometimes there are different types of tests as well. And they see if those tests fail. And if they fail, that's a good thing, because that means that your test has picked up on the change that the mutation testing tool made in your application. If your tests keep on passing, there might be something wrong there. Either your test is written for something that's never really exercised when you run your tests, or the test is written in a way that's not really all that reliable. So that's insight that a mutation testing tool can help you give. It gives you insight into the quality of your automated tests, and mainly in is any of my are all of my automated tests able to pick up specific changes in my application under test. So they are that's a great way to build tests that are much more trustworthy, which is basically what it's all about to me. I write automated tests to get information, and to get that information in a more efficient manner, opposed to when I had to perform that test manually. That's what test automation for me is, like getting information in a more efficient, information that matters, that's valuable, in a more efficient manner. And but that's only valuable if I know that I have tests that I can actually rely on. So that's it from me, basically. What I've covered in this talk is hopefully I gave you some insight into and some examples of ways that your tests can fail, that your automated tests can fail you, and not just fail as in to produce an assertion error or something, but how they can fail you by giving information that you can't trust, and that you how your automated tests can become untrustworthy. And we've looked at some tactics like testing your tests, reviewing your code, being very careful as to very precise in what is my test actually doing, and is it really doing what I think it is doing, and am I really sure that my test only passes when I want it to pass, when it should pass, And am I really sure that my test fails in any other kind of situation? And because only then do you have a test on your hand that's actually valuable and reliable and trustworthy. Thanks. That's it from me. If at some point, and we have some time for Q&A now. If I don't know exactly how much time we have, Ines. If at some point you want to get in touch, email's probably the easiest way, bas@ontestautomation.com, and I'm happy to continue the discussion there in case there are any questions or things that we don't get to in this Q&A session.
Awesome. Thank you, Bas. That was fantastic.
You're welcome.
It was really interesting hearing it, and specifically you had a quote there about do not rely on code coverage. It's not a good estimate about the quality of those tests. So that's something that's, I think, going to stick with everybody. Should we jump into some questions?
Yes, please.
Awesome. So we have one question here from Sebastian, who wonders about the percentage of failed tests versus passing tests. And he's giving an example, saying that we have over 7,000 automated tests on E2E layer, mostly Selenium and Rest. And he says we have almost always less than 3% flakiness. Is this a good or a bad statistic?
Well, dogmatically, I'd say there's room for improvement because there's still these 3%. What I'm curious is how do you measure that flakiness, and do you allow for and what's your God, and here's where you can tell that English still isn't my first language. So what's your I hate this. Is 3% acceptable for you? I can't tell you because I know nothing about the risks, and maybe going to production quickly is more important than having all of your tests pass, and that all depends on those tests that are flaky. Mm-hmm. I'm just going to assume that those flaky tests they concentrate on specific functionality or specific components and don't just pop up to the left at some days and to the right in some entirely different component or system in the next test run. It's without more information. It's really
tricky
hard
to answer.
It is impossible to answer if that's good or bad. If it works for you, it's good. And one question that I often ask myself, if I'm writing automated tests and if I'm including automated tests in my test run, in my build pipeline, is it am I comfortable in deploying this application into production without the information that I'm getting from this test? So that to me helps me identify how important the test is. And so if you say, well, I know this test is failing sometimes, but I'm okay with that. Mm-hmm. And then you're in a good place. If you say, well, no, this really needs to pass, then you've got some work to do.
Okay. Let's move on to another one.
Sure.
So we have Brian here who's asking, how did you choose the test that was passing? Did it cover a lot of different aspects of the application?
So I think you're referring to that first story.
I think so, yes.
The false positives where we just turned off all of the tests. We chose a relatively straightforward test, not something that touched all of the components, because we knew that the smaller we keep it, the easier it is to get it fixed and get it reliable. And for me, at that point, showing that test automation can be reliable was more important than covering all the different components and features of an application. Because the most important thing for me to do at that point was regaining that trust in the automated tests, because people completely ignored it. So we deliberately chose a relatively small test that still did so. It wasn't just, can I log in? It did something a little bit more significant than that. But it was a relatively small test, because we knew that that was probably easier to fix and to stabilize, and that was probably a good thing to build upon. Because we need to regain the trust in our automation, and you can add then. You can, of course, start with the most difficult one that covers all of the different things, but that would have taken us a lot longer, probably.
Yeah, that makes total sense. And I think that's all the time we have for the Q&A.
Are there any? Yeah, you need to switch to the next session. I have a couple more minutes. So if you have a final question or something, I'm happy to address that one.
There's one here about any recommendations for E2E test automation mutation tools for Java. If you have any recommendations.
So the most often used open source mutation testing tool for Java that I know of is PyTest. But it works at the unit test level. So for end-to-end test, the problem with mutation testing for integration and end-to-end tests is that you need to create mutants and then maybe redeploy your application at some point. With source code, you don't have that problem. So I know there are tools out there. I'm sorry, I don't know any actual names off the top of my head. I know there are tools out there that at least claim they can do it. I'm happy to have a look around and get back to the person who asked this via email or anything. But I don't know any off the top of my head, to be honest. Off the top of my head right now. The only thing I can come up with is PyTest, and that works on unit testing.
No worries. Yep, they were able to see your email address, so if anybody has some questions, they can maybe shoot you an email.
Yeah, sure.
Okay.
No problem.
Sounds good. Well, thank you so much, Bas. This was really fantastic. I'm sure everyone really enjoyed your insights, your tips, all of your insights about false negatives. And thanks again for joining us.
Thank you so much for having me and for being a great host.
All righty. Have a good day. Thanks again.
Yeah, you too. Bye-bye.
Bye-bye.